in a proper way, if we use, how it's going to help people through all the around the around to our institution, or otherwise in and around us. Like that, I can say, right? You see here, AI foundation models of global knowledge. So that already we know. So this is about the external. And when we talk about not only this, there are some AI foundation models of enterprise knowledge, whatever are there, they all will be shown in the type of AI enablement here. And other than this, the internal, like other AI models and frameworks, including uh, here AGI, right? So how exactly we are going to do? So here the generative info collections will be like this. So like the first part that will be taken, and then generative research, generative insights, generative info automation can be done, generative info innovation can be done, generative info decisions can also be taken. Yes, correct. There are many tools. So whichever you like that you can use, right? You are free, you are paid. Many are there. Like this, whatever you require, you can take, and which will be helpful to you in your area of expertise, you can use that. So next, coming to the AI-enabled knowledge work. This is the most important. So as I told you, we have to be use it safety. That means very safely, and ethics also we have to play important role here. Even the generative AI ethic, generative AI also what you are using, that also important, and compliance. So that is also we have to keep in mind when, because you all people, we all are in academics as well as research, doing research. So we have to. So here with this, we can also have pursue new markets like enhancing products and services, designing customer experiences, like imaging, imagining new products and processes, whatever you want to make it like a plug and play with AI technologies. AI technologies is not simple like word. Actually, it's a, I can say it's through IoT and sensor technologies combination of that. So that's why we can call. Otherwise, we can't. Generative AI means it's simply it's not that. It's a combination of all this IoT and smart technologies. With all this only we are calling. That's the reason now in tomorrow's lecture also I'm going to cover about the automation. So that means wherever to many people, it's how exactly the automation, because the whole world looking towards this direction. So automation means it's not just with the name of with the title of generative AI. It could be with IoT and other smart technologies based, right? With which will be embedded with all the in physical systems, cyber physical systems, uh, how in and how effectively and ethically we can use, like that it has to, right? And not only that, we can also create and using unique knowledge with respect to that, and communicating and collaborating we can do, making better decision support and first we can do that, and optimizing business operations, whatever we do. And not only that, business administration also can be done and can be, make it proper and in a way we can do that. And after that, gathering needed information, whatever you require that it can be. So this is the actual current stage of generative AI. All these things can does with this. Okay. So now, how exactly? So here, if you see the, I can differentiate this with respect to two. One can be called as discriminative uses of AI, and the other one we can call it as generative uses of AI. You might, many of you might be from computer science. You might have heard also, right? So discriminative uses of AI, just like it's called algorithm trading based on the predefined algorithm, or otherwise the algorithm you can build, or with the existing models you can do, and based on that you can work. But whereas coming to generative, like a generative adversarial network, like GANs, what we are calling. So with this, because at present we are going to use the GANs. So at present means GANs is nothing but the new term. Actually, they gave the new name, but earlier the same deep learning, machine learning models, the CNN model, whatever you are doing, a combination of this transverse learning means deep transfer learning models combinedly, we can call them as the generative uses. Okay, generative advisor network, we can call. So like that, it will be called. So here, what is happening here? So this we can call it as automated trading system. This is one of the beauty of this. So that is there in this generative, right? And whereas in discriminative, if you see dynamic pricing engine, and whereas here, if you see with respect to generative, you can find the real-time pricing mechanism. That may we can call it as dynamic, right? So real-time pricing mechanism, and even now the banking sector everywhere. I will show some applications. You will understand that. Okay. And next, ad spend optimization, ad budget spend, because it is indiscriminative, it should be spent. But whereas coming to here, ad budget maximization. This can be done. Demand forecasting is both, in both the cases it will be same. And any written task, whereas it is in discriminative, but whereas in generative use cases, it should be written task. Okay. So new materials synthesis by inverse design, that will be taken, and reverse engine for material creation. So reverse engine means here, based on the, sorry, based on the input, that means based on the user, based on the user, whoever wants to do or whatever the work they want to use, based on that they can work, right? Correct. And based on that, in which way they want to use and in which way they want to make it, they can plan. So like that, it can be worked out. So these are, so again, as I told you, dynamic pricing engine, this, and here both the cases is the same. I mean, but this is to be real-time pricing system. Now, whereas coming to understanding of generative AI, just here I covered the basic introduction to just to get an idea about this. So here, what is generative AI? So I can say that generative AI is, that means sometimes some people may call it as Gen AI, right? So, but we actually this is called as, actually its name is artificial intelligence, but that can create original content, can create original content. So that also based on the sophisticated combination of machine learning models, which will be with the help of deep learning algorithms that simulate the learning and decision making process, which can create the original content as such as text, images, video, audio. Already you people heard about this, right? Already you might be using also, right? Software code in response to users prompt or request. Like that, it has to go ahead. This is the basic definition of this, are uh, the statement which we can, and not only that, we can also make some decision making process of the human brain. So that means we can, with these algorithms that can simulate and learn and decide and can make some decision. How generative AI works, this is most important. So many of you might heard about this, the generative AI, how exactly. So there are total three cases. The three stages are there. How exactly the generative AI works means, so like the training, tuning, and generation, evaluation, pre-training. Like this, it has to. So that means here three stages like a training. So what we do with respect to the machine learning technologies, how we do in a similar way, it has to work. So in the here also we do the same. So how exactly it will work? So we can call like this, creating. So first one is training. So here the first training will be, for the most part, generative AI operate in three terms, like as I told, three phases training. To create a foundation model that can serve as the basis for multiple Gen AI applications. So whatever the multiple AI applications in detail, we'll see one by one. And coming to tuning. So tuning is nothing but about the foundation model to a specific Gen AI application. That means it has to fine tune with respect to the model and the model what you are using and how you are utilizing it, how you are going to work further, and how you're going to retune that based on the predictions. Like that, it can be worked. The next one we can call as generation, evaluation, and retune. To assess this generation AI application's output and continuously improving its quality and accuracy. So if we go in detail one by one, so here I give training. So as I said here, especially with the help of different models, like as a deep learning models, that's based on the basis. That means multiple different types of generative AI applications can be worked out. So how exactly? The most common, like here in everyone knows. Now we are calling generative AI. So that means mainly it depends upon the models. So here the models I can call it as large language models. Large language models. This is the one of the most important model. With this only we can do many of. That is the reason the text generation also how you are getting now by using ChatGPT or whatever Gemini, whatever you are using. So here you'll get with respect to like the what language models you are using. So here these LLMs are the most important part in this. So which has come as the generative. So this creates the next text generation operations applications. And but there are also foundation models for image generation, video generation, sound, music, art. If you want to have make some art, that also you can take, or otherwise some art, some ancient big monument pictures also if you can take, and from that also the articulation of that also can be taken from that. Sketches can also be taken, so which can support in several kinds of content generation that we know. So may these all things you are getting, or we are using, we are enjoying it because of the various large language models. So in that, the most important the part combination of this we can take it the called as generative adversarial network. Okay, so that we'll see in the coming slides. So this whole process can be covered with of intensive, time consuming and expensive, right? It's total training process. It requires thousands of clustered graphic process units and weeks of processing, all of which cost millions of dollars. Right? So if you want to make, right? So in this case, if you do that, so here we have open source foundation model projects such as Meta, Lemma, Enable. These all are available already. You know, right? You might have heard also. Developers to avoid this step and its cost, right? Because it's open source already. So coming to here in tuning, so especially in tuning here, the when we call metaphorically speaking, a foundation model is a generalist. Like it knows a lot about a lot of types of content, like but often can't generate specific types of output with desired accuracy and fidelity. So for that, the model must be tuned to a specific content generation task. This can be done in a variety of ways. How exactly? So that will be done by using a prompt that means based on the keywords, what exactly you are using, and which type of keyword you are going to use, and how you are going to retrieve. So that means it should be clear. But even if you won't write it clear also, but sometimes it will take the assumption may be wrong. Right? So these are the few problems are there, but still, yeah, if we give it clearly, it can fine tune and it can give the information clearly. So the model work clearly, but the exact information what we are seeking that should be clearly mentioned. Okay, so you have to give that. Based on that, the correct answers will be taken. So here, the most important, one other important, we could call it this here, that is reinforcement learning with human feedback. So as I told you just now, that means what we are seeking. So we should be clear what exactly you require. Based on your keywords only, it has to judge and it has to predict the words and it can give to you. Right. So the most another important point here when we talk about mission, human and mission understanding. So then here we have to call it as reinforcement learning back system also. Yeah. So with this only, again and again, if you want to modify or you want to generate, you can do that. Right. And this also provides with greater accuracy and it will update relevant information. Right. So this is about the tuning of the second step of this generative AI model, how it works. So this is about the tuning. Coming to the third, that is about generation evaluation mode tuning. So in this case here, especially when we talk about generating evaluation mode tuning. So that means what we are doing, we are generating, and immediately after that, we are also uh, producing some information. So here, when we talk, especially with developers or otherwise users, whoever are continuously access these apps or otherwise these systems, right? So in this case, how exactly they're going to make? Like I can give simple word, I can call it as a retrieval augmented generation, correct? Right? So retrieval augmented generation. How exactly it can be done? So it's nothing but it's a framework which can generate, means which can extend the foundation models from the basic foundation model to use with respect to the relevant sources what you are going to use based on your exact the training data what you are going to. So like that it helps. And this is the one of the most important. And through these all these evaluations only here next we are going to get the generative AI models. So the all these generative AI models will be taken as this already I covered based on this retrieval augmented generation. And with respect to this, you can get the information clear. And next, generative AI models. So as I told you, generative AI models are with a bit of total 4 different types. Here I'm covering here about the variational autoencoders, and the other one told you already, that is generative adversarial network, and the other one already we know the basic model, that is called transformer. The transformer already you might heard, right, which we use in natural language processing. And transformers also works better only when there is a attention as well as a self-attention, right? So based on that, the natural language models also, these are actually basic models. So now among all this, the most latest one we can call with the LLMs which we are using, that is called, that is the generative adversarial network. Okay. So coming to here, the first, if about this, how exactly they have come. So here I given the true generative AI models, that is especially already I told, with the help of different models, whatever we are using and how we are going to work with them. And here I just given a historical evaluation, like how means how it has come, means to get this generative AI model. So here we have total three different, as I told you, variational autoencoders, this which drove breakthroughs in image recognition, natural language processing, and anomaly detections, especially. And generative adversarial networks and diffusion, we can also call it diffusion models, it improve like accuracy of previous applications and enable some of the first AI solutions for photorealistic image generation. It doesn't mean that it's only for only for image generation. It works for all data set. Okay, and transformers. So here, the deep learning model architecture behind the foremost point. This is especially, as I told you, the most important point and model we use in transformer, that is called attention and self-attention. Okay, so through this, with these all the this that's why this is the foremost foundation model and generative AI solutions today. So with this, how exactly the variational autoencoders work? So how this will be? So here an autoencoder is a deep learning model, as I already told you, comprising two connected neural networks. So it will be taken with of two neural networks will be taken together, and this was introduced in 2013. So it's not the new one; it's already available. But uh, based on that, how the usage and autoencoder will be taken with multiple variations of the same content will be used to get that. Like that, you have to. So like this, already people are using it. So, and one more important, this it also is a particular goal. It can zero in. We can call it zero in on more accurate, higher fidelity content over. This is also another important parameter we can. So as I can tell here, like, like simple example, like how they compressing data from storage or transfer data and decompress it for use again, and like for high quality content, like that information, whatever you do in these cases, it will work. So here, this is about the variational autoencoder, how exactly we can use. And here, the early, like early VA is application, like anomaly detection example, like medical image analysis or otherwise satellite image analysis, some anomaly like we can't find, but something that, so anomaly identification with the help of satellite images or otherwise in medical images, these models can also, earlier they used for, especially for these models, right? So coming to the next one, that is about generative adversarial network. And this is the most important, and this was introduced, this is also not new, but we are calling, mostly we are using now, but it has come in the year 2014 only, right? So again, this is also with of various neural networks, and these especially these models which evaluates the accuracy and quality of the generated data. So that is the beauty of this. So it works with two actually main things, but one will be called as discriminative and the other one will be called as the generative. So like this, generator which generates the new content and discriminator which evaluates the accuracy and quality of the generated data. So like this, it will work. So this is the combination of the work, how exactly the GANs will work. And in this, these adversarial algorithms encourage the model like to generate increasingly high quality data. And not only that, even we can also put high accurate quality realistic content across various domains. That also can be taken. So here the image and video generation or otherwise generate high quality realistic content also can be. This is all about the generative adversarial network. This is only just introduction I'm giving you, and I will give you the more detailed information about this when I give the block diagram of generative example. Okay. So coming to here, a diffusion model has this same. Again, this has been used along with the generative AI. So this also we got in the year 2014, and especially this here also. This is mainly especially for training the algorithm, especially to iteratively, that means to iteratively diffuse the noise to reveal a desired output. So like that, it has to be taken. So like VAEs are from GANs. Uh, Whatever the train will do, that can be done through VAEs or otherwise scans also can be. And not only that, even the other sources we have like DAL-E, Open as image generation tool is also driven by the diffusion. These are the models, diffuse models which we have. Next. So these all are available. So if you want, you can use and you can go through already few of the computer science academicians might be using in their research or otherwise in their teaching or otherwise somewhere in their research activities they might be or in project phase also they might be using. I guess so. Correct. So coming to here. So what exactly this? This is about the generative advisor model. So what exactly it is? So here, I would like to highlight here the few important things like see here, just observe the model. So this is architecture. So for, this should be taken with a generative model. Like see here, as I told you, we have two. One is the generative model here, and the other will be the discriminative model on the right hand side. And like correct. And here, if you take some example, like some examples, and with respect to those examples, randomly it can pick, and first we can check one step by step, and based on this, how exactly the model works. So here I give like a real example, and some fake data also can be given, and which can be generated through generative model, and that can be taken to descriptive model, discriminative model, up, and there again it gives the accuracy again, right? It works on the evaluation and quality of the data. So it does the binary classification of real and fake, and then based on that, it updates the model. Like this, it processes. Again, it takes the input, again, it whatever the generator does, that will be taken, and again, the discriminator will find out from that for the quality. Like this, it gets. Like I can say, like a generator's task is to create, and whereas some information like fake or otherwise random input values with respect to that it can create. And whereas the discriminant role is to distinguish between real and fake. Okay. From there, again, from the output produced from the generator. Like that, it has to take. So ultimately, the generator and discriminator implemented as a convolutional neural network. You're getting my point? So like this, that's the reason I told initially. So continuously this challenge and learn from each other. So that's why is a convolve with each other and can generate the quality. Like that, it will work. And more ultimately, the best one here is to improve the quality, okay, and the response time. This is the most important and what we can discuss here, right? So like this, the model work and it will. This is just for understanding purpose. Again, I gave here, right? Coming to the next one is uh, so like as I told, GAN involves two neural networks to generate like discriminant and against zero sum game. As I told, the generator's task is to create convincing fake, as I already explained, right? Just for your understanding, I kept here. And this typically implement the convolutional neural network. So coming to the next one, that is transformer. So as I told you, right, in natural language processing, if you might have taught natural language processing or otherwise you might be teaching, you may know, right? So how the word embedding happens, correct or not? So in this case, if you see the same diagram I'm using here, and this transformer also has come into picture in 2017, okay? And this was the data I had taken from Ashish Vishwani from the paper. So this is the literature I had taken, studied. From there, I took this one. And how exactly the model trained the data and how the quality of information has been produced. Okay, and these models are the core most of today's headline making generative AI tools, including ChatGPT, GPT-4, Capilot, Bard, right, Midjourney, to name a few, right? So all this does the same initially. So these transformers use a concept called attention, as I told you, right? Attention and self-attention. This is most important step which we use here. So, right? So those who taught or others teaching natural language processing, so you may seen this, correct? So how exactly, I mean, the sequence of data, sequence to sequence, how the sequence of data words will be generated, like a parse tree algorithm, through the parse tree algorithm, how the parsing of the words can be done and word embedding can be taken, uh, how it will work, right? So like, so here I given the, based on that, how exactly the process step, sequence to sequence words, how it will go into, right? So here it will be processed like this, sequence to process entire sequence of data, example sentence instead of individual words simultaneously, right? And capture the context of the data within the sequence. Okay, we call it as through parse mapping, a parse tree generation. Through that, it can, and not only parse tree, there are many things out there. Even grammar, context-free grammar also comes into picture, right? So with the help of context-free grammar and all these things, this has to be, and it's not just simple, but we are getting the information. But back then, it works like this. Okay? But everything we are getting in fraction of seconds, right? So those are taught this subject you might have heard, right? So encode the training data into embeddings. This is called, which I was saying, it's word embeddings. We call it as hyperparameters called, right? So from the word, what the keywords you give to that. Based on that, it works like that. Okay. So how exactly the transformer architecture looks like this? You see the diagram here. So this is the diagram. If you see, those you have already, as I told you, this again I took from the natural language processing. Okay, concepts only. So this is the transformer architecture. If you see here, here input embedding as well as output embedding. So how it is exactly going? Actually, this will be done in two ways, like encoder and decoder. Like how it's like the convolutional neural network, how exactly. But here, this information, that same thing does the similar way, but in the, it should be worked in a cascaded manner, cascaded, like multi-head attention, okay, multi-head attentions, right? So in that way, it has to be taken. Again, we have the addition, normalization, everything we do, and after that, multi-head attention, everything will be taken. And few wherever you require the mask, you can do mask multi-head like that. It will go like that process. So this is the actual way how exactly it is. And once it is linear, and this will be the softmax for the output probabilities. And at the same time, the output embedding words also be taken. Right? Like this, it's a continuation. It's not one. But this is the only the model for which we call it as for the transformer. But this works exactly with respect to the word what you are getting by using ChatGPT, and this works through this model, right? Transfer model operates in two stages, like encoding and decoding, as I told you, right? Encoder extract features from the input sequence with through embedding, right? And transforming them into vectors in the form of vector analysis. And from those vectors represent the input semantic. Actually, it takes the semantics of from that and and at the same time position aspects. And then these vectors are then passed to the decoder, okay, which derives context from the them to generate the output signal. By adopting a sequence to sequence learning approach, transformer can predict the next item, like in the sequence. Next item is nothing mean next word, right? Next, exactly. And it should follow everything. It's not just like a word. It should follow the grammar, like a context-free grammar. What exactly, whether it fit to that particular sentence or not, like that, it has to be taken and adding context that brings meaning to each item. Like that, it has to. That's why we are enjoying it, right? So these all are only the basic theoretical concept I'm explaining you. Now I'm coming to the innovation, how exactly working with respect to industry, that I will in the coming slides, I'll show it to you, right? So key to the success of transfer model is the use of attention of self-attention mechanism. This is the most important, as I already told you, right? So this is, with this only, this works. So these techniques add context by acknowledging how different data elements within a sequence interact with and influence each other. Same sentence, again, what you got, if you want, again, you want to make it different, you can also look for that. So that also it can give you the same perception, but in different words. Like that, it will work, right? So the major architect here, so the The generative AI has witnessed remarkable advancements in recent times that already every one of you does know, right? And with respect to this, here I gave a few points already. These are the existing models, open source. Now, and few advantages like what we can do because advancements like not standalone instances, they are culminating scaling model, growing data sets, and enhanced computing power, all interacting to propel the current AI progress. So in this case, especially as we know, in 2023, March 14th, 2023, March 14th, as I starting, I said, last year onwards, we are enjoying this, right? So that means GPT was released, OpenAI, correct? So which incorporates, that means the history of its conversation with the user into its results. Like as I told you, right? Reinforcement learning with human feedback, reinforcement learning with human feedback. That has made it into existence. That is the most beauty of this. So real conversation started happening from 2020. Correct or not? So with this, how the innovation can be taken into or can be taken into industry or any field or any domain, how we can transform digitally and how we can make it use of it. So these things I'll see I'll cover. Just only two slides. I'm giving you the historical evaluation, how it has come, right? So this is about 2023, March 14th, as I told, GPT-4 has been released. That is the beauty of this. And 2022, like instruction tuning emerged, like significant advancement in generative AI space, they initiated in 2023. And even the LLMs also has started tuning with the help of the same model. Even now we are using it, right? So in many companies now they are directing towards the language models, different language learning models. So with that, how exactly they're going to? So even if you want to start up a startup to give to different companies with these you can give a particular language learning model to a particular company, so they can work on that. Like that, if you are good in this, actually, you can also make that as a freelancer. You can do and you can make your own work activity and you can make your own startup like that. You can also start like this also you can work. So as I told you, so these all reinforcement learning with human feedback, right? So this is the main instruction which already, right? In coming 2018, the advancements of transformer, like as I told you, transformer, right? So model like and GPT-2, that was initially with of only the transformer, just only with self and the attention and self-attention model they used initially. And this actually based on the pre-trained transformers models were designed to generate new words like that they used in that. In 2017, there was a Google's transformer model. Right? So like that we got, that was the first natural language program processing sector where deep learning had previously struggled in 2017. Okay, so these are the historical evaluations that I want to highlight to you just to have an idea how this has been. So this already you may think, sir, AI already there in 1956 itself, correct or not? Professor Curie has given in 1956 itself, but the evolutions, the changes, the means how exactly we are going to use in better way, best way, like that we are coming up year by year. There is so many evolutions, correct? So based on the data also, based on the digital information, based on the digital information, digital data set, how exactly we are going to make. Correct? That's why we got, now we are in that era, right? So we are enjoying that. So you can also make your own like that. And here, especially in 2017, not only with this, especially with respect to transfer model, we also used especially NLP task or computer vision task like the machine vision also started, right? So there also they used initially. Okay, so now if you go in later in 2012, earlier, like the dawn of the modern AI era data back, like with the deep learning and convolutional neural network, they started. Like initially, like what we call ImageNet, AlexNet, you might have used, correct? So based on that, they use the data sets. Even ImageNet and AlexNet, if that was not there, data set, the CNN won't be that effective, correct or not? So like that in 90s itself it was there, but later on the data and the learning techniques have been increased based on the data set, which are based on the availability of the data set, right? So like this it has come. So these are the few historical evaluations I want to give it to all. So I'm not pointing on this. I don't want to spend a lot of time on this. So like this AlexNet comment, as I already told you, right? So this was at the time. Now, where do we, so how exactly? The state of large language models. Okay, so here the present state of each and everyone, if looking for this, for each and every sector, they're going to different large language models. Okay, large language uh, learning models. So what exactly, in which way they want to, but they should be proper. So if even you, even already I'm working for one company, but I given a one model, language learning model. So based on that, means I just given, I give for them on for Singapore, actually especially for Singapore company, I give that is augmented and AR/VR uh, system. For that, how exactly they're going to work in that particular company. For that, they're using a large language learning model. So like that, how we can work on that. And like that, you can think and you can also give the content, like the content. It's not only you have everything is there now. You have to make use in their domain, and you have to use that also ethically. Oh, exactly. And it should not be affect the other people. So that you have other companies also. So when you are in digital, you have to be very careful. So whatever the APIs, whatever the LLM APIs like OpenAI, Cohere, and Anthropic, whatever you are using, so you should be clear. Okay, so you have to follow that. You once you practice once or twice, you will get that. You can work on that. Okay, so like this, on the consumer product like ChatGPT and Bing offer access of LLMs, simplifying interaction and their advanced models. Like that, we can. So why can't we come up with a particular sector only with a particular LLM? How we can do? So like that, the people are working and people are already using it. So now many companies also looking to move in this direction. So this is the present stage. So I will show you the global market, how exactly they're looking. But till 2031, I give, I'll show to you. Okay. So with this, these are the various developments, research and developments, and which can be helpful to each and every one of you, even if you are in from computer science or from other domain also, you can make use of it and you can also earn something. You can start your own business or otherwise your own startup in this domain like this. If you have any questions, we can discuss. Okay? Like that, you can think and you can work. So this rapid race for this development raises several important questions. For instance, what will be the most common ways for people to interact with LLMs in the future? Okay, like this, if you think, you will understand. Okay, which organizations will emerge as the key players in the advancement of LLMs? So, like these questions, if you think, you can come up with that. So, with these questions, next slides, whatever I'm going to show you, you will understand. How fast will the capabilities of LLMs continue to grow? Right. Next, give the balance between the risk and controlled outputs and the benefits of the democratized access of this technology. What is the future of open source elements? Right. So here, this is the table I given as the release date. Already I covered the few important points. Just I given the table here for your understanding, your learning. You can have a look of this. Okay, later when you get the slides to this. Now, so here, how exactly the generative AI model invented. Here, improve customer experiences, and it can create content on the fly, facilitate client services, boost personalizations, improve task efficiencies, develop new products, and spur knowledge management. So these things can be done. Getting my point? So these all things can be done. How? So here I can say the most important point in this case here, the first, when we see the global market, here you can understand. If somebody is using annotation, so could you please stop that, if you don't mind? So here, if you see how the CAGR is going to raise, right, in terms of billion and to be in dollars. So here you see the growth drivers. If you are good in this, if you want to be in this direction, you can plan in this way, right? This is the market size which is going to increase by 2031, right? So how, what exactly? So that means what you have to do. So because this is the main important point where exactly you are going to comment. Actually, why? Because I have gone through the various websites and I have taken this, and there is a growth, sudden, there is a drastic growth up to it, I can say 32%, right? Uh, Correct or not? So how exactly? So it's going to means not only this, in this we can also say that we will employ visually captivating PowerPoint like light in the capabilities like impact and potential of generative AI across various sectors. So how exactly you can cover, right? And in this case, you can also become a crucial, especially in this generative AI is going to become a crucial tool for innovation and efficiency with this, correct or not? So in this case, this is what I would like to give you. And the major players here, if you see, they are the like OpenAI, Google, and Microsoft lead the market with. And even the recent article you might have heard on 19th, this 19th, today is 21st, right? 19th, the Microsoft CEO announced he's going to invest around some billions of dollars, right? So especially on OpenAI, on this only, right? On generative AIs in India is going to invest, especially for AI models, powerful AI models to generate for research and development. So see there, there is a job opportunities also there in this domain. So you can think it's going to start now, right? So you think in this direction. This is the new article, news, recent article on 19. Have a look of that in Times. Okay? So this is about the global market, how it's going to change. And here, the drivers you required as I given here, it's like artificial like models, like learning. I can call it as a new term called deep transfer learning. Deep transfer learning. Okay, so if you have this personal skills, or if you use these develop apps, develop apps, or otherwise OpenAI, NVIDIA, these things, if you use, you will be you'll be in the next 5 years, you'll be in a good position in the coming years. So you can think in that and you can start your own. Otherwise, you can also work with various companies and you can make. This is the market size in the coming. Now, if you see the trends, especially in the, if you see in the market growth, how exactly it is going to change, right? So here, this slide especially, so someone again using this annotations, could you please stop? Don't, I request, please don't do the annotation, right? Annotate on the screen. So coming to here. So see here, I given the few four important domains in this. So like multimodality, software development, medical research, and hyper personalization. So these are the trends driving generative AI market growth. You see, so in these domains where your expertise falls, like that you have to think. So where exactly in which domain you are good. So think in that way. So uh, take that point and you can work. So you can come in that way. You can think and you can plan and you can come in that point. So here you can think and you can also come with your information like how exactly in terms of software or otherwise in terms of product coding or otherwise in terms of writing skills. If you have how in which way you can do, you can come and you can play with that. So these are the most important driving trends you can follow and you can use them. These are the important points. Okay. Right. And next, coming to the supply chain, if you see the innovation, how exactly forecasting this, if you see the demand forecasting, so especially here it's about demand forecasting, supply chain optimization, and like supply risk assessment, and the other one is route optimization like this. If you see all this, there is a unique importance, right? If you see forecasting, so this enables about the business to optimize inventory levels. What are the inventory levels? And reduce stock outs and improve overall supply chain responsiveness. Like these things, they can think and they can work. When it comes to supply chain, it should be like the algorithms, like how generative algorithms will be work, like streamlining production, distribution, and inventory management, resulting in reduction cost, right? Increased productivity and improved customer satisfaction. Like these things can be work. Like this, how the people are using. So in this way, you can plan. And in like this, if you come like optimization, risk assessment, in especially in risk assessment, how it's how this generative AI tool in terms of cybersecurity, how it's going to mitigate the risk in the supply chain. So like that, the risk management also can be worked on that. So like especially for the supplier reliability, businesses can proactively identify and address them, right? So like this, they can track. Next is the route optimization. When we talk about route optimization, here also, especially the optimization logistics, like transportation routes, like considering factors such as distance, traffic patterns, these things can be think and based on that, how to minimize the fuel consumption like that also, and reduce transportation cost. Like this also, they can these are the points, especially for route optimization through generative AI. So like this, we can think and we can work. So this is about the next point about the commerce, means e-commerce. So especially in e-commerce here, like individual shopping assistance, customer services, because nowadays because many things are available, right? Yeah, because we are in social media. So in social media, we can do whatever you want. You can make, or you can purchase, you can publicize, or you can also market or self-market also you can do based on your this. So this is the platform where we have, right? So in this case also here, like individual shopping, customer service, content creation, and social media campaigns, like customer service, but like you can make uh, like efficient chatbots like that, and I can also say another virtual assistants, correct? So like this also you can plan. When we talk about individual, like individual shopping assistants, like we can provide personalized product recommendations like that also you can make. Already few apps already they are doing Amazon, but in that way you can plan and you can work, you can come together. Like, automated content creation to save time and resources, that is also another important. And optimize the social campaigns, correct? Social media campaigns for targeted audience engagement. Like that also you can work. And like this, if you do, then it will go. So with these continuous advanced generative AI will unlock further profit generation opportunities and elevate customer experiences. Like this, you can increase the e-commerce industry. Like this also, we can come. Like, and if it is come when we talk about the fintech technologies, in fintech technology, especially we can plan on enhanced marketing like sales assistance, relationship management, these things. Correct. So enhanced marketing campaigns when we call like we can say that just with by using generative AI, we can also personalize marketing efforts can be increased, and also optimized advertising strategies can also be increased, improve lead generation for higher conversion rates. Like that also, it will work like that. And when we talk about self-assistance, especially this generative AI plays as which provide intelligent product recommendations that can be improved, right? Cross-selling opportunities and real-time customer support to boost sales and enhance customer satisfactions. Like this, you can do, and you can work on that. When we see about the relationship management, especially like this generative AI can aid in relationship management by analyzing the data to offer personalized financial advice. Right nowadays, already few apps providing that. Right, so like this, how we can go. That means based on like product offerings, or or otherwise, if we want to improve client retention rate, like that also we can work on that. Okay, so this is about the generative AI, especially in fintech technologies. And when we see about the, especially when we talk about banking industry, so here the few important steps here we can follow, that is about the fraud detection, personalized offers, and risk management. So here when we talk about the personal like fraud detection and because fraud detection many, because nowadays there are many cyber attacks are happening, correct or not? So this how this generative AI aids in risk management, like how based on the historical data and market trends, correct? And we have to make it as a proactive risk mitigation and regulatory compliance. With that, it can also work to work. So you can think if you are expertise in cybersecurity, you can think and you can come in that direction. You can work like that. And by embracing this generative AI in banking, it can be actually operational excellence, like the operational excellence and drive sales growth in their financial product offerings, right? So like that also can be work will be back work better, right? And not only that, we can also we can also improve marketing efficiency, like include Marks and Spencer, Metal, Hinge, and Steel. Like this, many other in terms of different products also we can help with this. Like this, we can help, and financial product offerings also can suggest to the people. And when we see about the marketing, so here especially when we take a bit marketing like this, here when we talk like market Spencers, like here like Battle and Hence, the Stitch Picks, right? So these are the other model which we can use here, like especially the AI technology which we use to, especially for digital, means how exactly the digital information can be. So the power of generative, how we can use it to innovative content, like for their uh, like toy promotions or otherwise from product promotions, we can say, right? So like that. And if it when it comes to in this case here, especially the dynamic and attention grabbing to be concentrated. So how this will help in their campaigns, like this generative AI. So how like that it will be taken. And when it comes to Stitch Fix, like Stitch Fix means it's like the personalized fashion. How we can give the personalized. So we can give some prediction with the costume or the design or the uh, we can what called uh, fabric, whatever is there. Based on that fabric design model can also be changed. Like that model can be built and can, right. So like this also we can work. There is another example. And the next we come to marketing, like marketing and advertising. So now we can also, because many people are also using now, so like advertising their model or otherwise their product, how they are going to use, because they're using ChatGPT and advertising. So this will also increase the content, like the catchy means to make uh, audience attractive towards that ad, how they are going to do. So with what to be done. So like these content captions or the catchy words can be taken from here and can be done. So like this also you can work, and for this also you can create a language models, and you can give large language models, and you can give further. Like this is the another one we can use, especially for advertisement and uh, marketing. Next, coming to the next most important, that is about the sales strategy. Like use cases are in different sales stages, like prospecting and discovery, right? And presentation and evaluation, like negotiation, closing, retention, and upsell. So here in these cases also we can work like in what we call we this generative AI play important role here, like how exactly in processing, like in prospecting, like generative AI enables intelligent lead generation and targeted customer outreach, right? And that is about the first one. And during evaluation, generative AI aids can also be in data analysis, like the predictive modeling and customer profiling to enhance the decision making can also be used to enhance to work in that. And especially we can also call like in negotiation, like intelligent pricing recommendations and personalized proposals can also be used. So like this, you can generate the content, and you can also uh, create some generate some large language models, and we can use. So like this, the by by leveraging the generative AI model can be used in different. Like this, we can coming to human resources. So generative AI, especially use cases in human resources. So this is how exactly, as I told, like content creation, recruitment, and onboarding, and performance management, and HR automation. So especially when you want to recruit a person, or otherwise you want to shortlist the resumes, or otherwise you have to take interview, or in which way you are going to do. So here nowadays even we are doing this online also, right? Many people are doing, right? So there also they can create an online system which can the system model it the system itself does the entry, like take the basic information. So like we can also create like performance management benefit from generative AI, like performance management from the data analysis and real-time feedback generation. Through that also we can do, and HR automation especially involves in streamlining the productivity and the overall workforce management. Correct. So like this also it can right? So like this, we can create some handbooks like HR materials, such as job description and employee handbooks like that. And in recruitment, especially, AI algorithms can assist in candidate screening and shortlisting, saving time. Also be and these models can be worked on. So this is another application innovation domain in the human resource, and this is about image and video generation generative AI tools. So as already we have many models, as I told you here, if you see image generators, we have tools like DAL-E, Sterai, right, Carrion, Nightcave, right, Artbida, Beta, Synthesia, Lumina, and FlexiClip. These are the center stage in this slide, right? So that means these are the main important point. So here pricing and the free version which are available, you can also Google it, you will find. And for video generated tools also we have, these are the video generated tools, but you can you can also you can sign up and you can make use of that, and you can, so like this you can create whatever you want in the design, or otherwise whatever the unique, because instead of taking from Google you can create your own. So like that you can make, so these are the source already tools available which you can use, make use of it, and you can make the content whichever you like, okay? Or in which way you want to make. Right? So here, voice and music generator AI tools also available. Here are the few tools which I give here: music generator and voice generator tools. So by using this also we can use, because especially this few libraries, especially in assistive devices for visually impaired, also we are using. Right? Already in one of my research I have used. So like this is very effective. Means useful to each and everyone. So in which way? Because but that could be you have to use it ethically. Okay? So there are many innovations in which way you have to use and make use of it in your area of expertise, and in which way you can give access, easier system to the audience. Like that you can think and you can work if you are working with this in a particular respect to particular research work. Okay? Like this. So next, coming to the pricing, that is AI tools. So here we are having tools like pricing, right? So free trial, these are the few uh, raise ID like tools like Writer, Jasper, Copy.ai. So, okay, you can Google it and you can find. So there are many. So here few free trial also there, and few some are chargeable. Okay, some are monthly or otherwise yearly per month, like that also there. You just go through that and you can make use of it in your research or otherwise in your academic. Or if you want to work with a particular idea with respect with some student, if you want to work, you can suggest them, and students can explore more on that and can work together on that particular. So that will help, right? So you can make instead of going just taking from the Google, you can also create some new content like that, right? So here the code generate AI tools for developers. Here are for the developers. These are the few tools available, and then so you can use of this. Okay, and these are the genuine and also available. You can go and check with them, and you have to register and you can make use of them how you want to use them. Okay? So these are the few I would like to give AI tools for developers, so you can make use of them. The next potential future in the market. So here, this is the most important in various different industries. If you see here, finance, entertainment and media, creative industry, education, marketing. So here, in means in different in all the aspects in each and every healthcare, especially in healthcare here, this system can give you that it can diagnose the uh, personalized medicine and otherwise drug discovery and drug discovery. These informations can be and through in healthcare. Like that system, you can come up with will benefit. Correct. In education, especially by using these tools, you can also personalized learning and content generations also can be created from that. If it is in finance, by using these algorithms, you can also enhance the risk assessments, fraud detections, and algorithmic algorithmic trading. Like that also you can come. Like this you can plan. And if it is in entertainment and media sector, you can Also content creation, visual reality experiences, these things also you can think. So coming to the last slide, how this is going to be in future, how it's going to impact the jobs on jobs. Here, this is a small analysis if you see here, but there are millions of especially in generative AI, you'll have a lot of future. As I told you, there is a growth. So there are totally, yeah, yeah, here, especially there you have, if you are in expertise, you can come up with your own expertise, you can do, but it's going to affect, especially in these few domains based on my literature I have given here. If you want, you can go ahead, just have a look of it. You have generative AI, you have job positions, even these at the same time affects how few tools affects some gives create some impact on the present jobs, right? Especially in marketing, correct or not? Advertising, marketing, these few cases. But there are few. If you are technically good in by using good in using the tools and developing, especially in developing tools, using the tools, AI tools. If you come up with your own model and you can work on your as a freelancer, like this, you can go. Is what I would like to cover and the generative AI for innovation various. Yes. Okay, so thank you for bearing me. If you have any questions, you can please. Thank you for giving me this opportunity. Thank you, sir. So if you have any questions, please. I hope I taken from the starting introductions, basic concepts to the innovation, how AI, generative AI, how it is taking lead in the various domains. Right? Good. Thank you. Over to you, sir. David, sir.
Yes, sir. Yes, sir. Any queries? The participants are free to ask. Sir, are there any tutorials, sir, to learn this Gen AI in efficient manner freely, sir?
Yeah.
Are there any courses that is available online?
Yes, sir. Available, sir. I'll
Free,
share with you, sir.
free of
Yeah, yeah.
free of cost, sir.
Free of cost. Yeah, yeah. There, sir. Already available. I'll share.
Okay.
I'll share with you.
Okay, if no queries are there, let's move with the third session. Thank you so much, sir. On behalf of all the participants, I extend my heartfelt thanks to you, Dr. Suresh Mergu, sir, for such an engaging and enriching session on the generative AI for innovation. The way you brought life to the topic with the practical examples and explained the applications of Gen AI was simply remarkable, sir. Your session has left us inspired and more curious about exploring Gen AI technologies further, sir. Thank you for your valuable time and for sharing your deep knowledge with us. We look forward to stay connected and learning more from you in the future, sir. Again, we are going to have your session, sir. I think tomorrow.
Yeah. Okay, sir. Thank you, sir. Thank you so much.
Yes, sir. We will meet tomorrow, sir.
Yeah, sure, sir.
Thank you so much.
Thank you, everyone. Thank you so much.
Thank you so much, sir, for your enlightening PPTs and
Thank you.
good
Yes.
presentations.
Thank you, sir.
Madam. Okay, let us move to the next session. That's about cloud platforms for AI deployment. We will learn about the various cloud platforms available for deploying and managing AI model scale. Yesterday already we had the talk with our Dr. SVG Reddy, sir. Once again, just I will give A glimpse of his introduction. It's my honor to introduce Dr. S.V.G. Reddy, who is joining us today. Dr. Reddy, sir, is currently serving as an associate professor in the Department of Computer Science in Getham, D-2 University. He brings with him an impressive 22 years of teaching experience in the field of computer science engineering. His specialization includes machine learning, deep neural networks, bioinformatics. He completed his PhD in JNT Kakarana in 2020. Over the years, he taught almost 20, 30 different subjects in computer science and added branches. It demonstrated exceptional versatility and depth in teaching methods. Further, is in passion to learn, teach, and mentor and serve the needy. Sir. He also significantly contributed for academia through various publications in Q1 journals, Web of Science, and Scopus Index journals. His participation in FDPs at IITs and his role in organizing similar programs showcases commitment to professional development and knowledge sharing. Now, I hand over the session to our SVG Reddy sir to proceed on this cloud platforms for AI deployment. Already, Suresh sir gave a lot of information on this Gen AI. Sir, I'm requesting you, sir. This is the interdisciplinary group of people are there, sir. Reddy sir, are you there?
Yes, sir. Yeah.
So you please go with the fundamentals of this cloud platform, sir. I'm
Sure,
requesting
sure,
some management students are there, MBA students are there, pharmacy students are there.
Okay.
So you go with outlines of these cloud platforms, and if it is feasible, try to give one example at least to how these deep learning things can be used with can be utilized as these cloud platforms.
Okay.
Any like Google Collab or something like that, sir.
Okay. Okay.
Just try to execute some problems, sir, so that we are always we are getting the words of multi-layer networks, or deep learning or something like that. Just you give us glimpse of this how this deep learning things, otherwise this multi-layer networks will work within the cloud.
Okay. Sure,
Thank you, sir.
sure.
Now I hand over the time to you.
Yeah, thank you so much for David sir, like once again giving the introduction, of course. Thank you so much and thank you for the opportunity. So yeah, welcome back to all the participants of this FDP. And of course, I thank very much for my good friend David sir, and then my heartfelt thanks to the HOD ma'am, Jai Kumari madam, so Department of CSE Vasu Engineering College, for giving me this opportunity. And of course, welcome back to all the people, all the participants. Yes, so let's start the topic for today. So this is the topic, of course. So learn about the various cloud platforms available for deploying and managing AI models at scale. So of course, our David sir has asked me to go with the basics, of course. So then, yeah, so we'll understand the cloud basics, and then we'll see what are the platforms available and what we can do. Is it the paid one or is it the unpaid one or free services? So let's understand. So of course, I'll try to implement the one of the deep neural network, that is convolution neural network model. So then we'll see how it exactly works in the Colab. So what is the advantage of Colab also? Let's understand, of course. So slowly we'll go now. We will understand the basic concepts, and then, yeah, so this is the content. So if we see the history of the cloud, right from the generations. So initially the ARPANET has come into picture in 1969, and then the virtualization concept was in 1970. And first time cloud computing is defined by Professor Ramnath Chellappa in 1997. Okay. So then, of course, we got this Amazon has launched Elastic Compute Cloud in 2006. Sorry for that. And then the Worldwide Public Cloud Services in 2013, and then in 2014 also we got some estimated global cloud spending there. So people got more exposure. So in the recent days, like all the people are almost showing affinity to use the cloud services. Okay, so this is something about the history. And then basically, what is a cloud? So a cloud refers to a distinct IT environment that is designed. David sir, is my voice, is it clear? Audible?
Yes, sir. Audible, sir, audible.
Fine, yeah. So thank you. So a cloud refers to a distinct IT environment that is designed for the purpose of remotely provisioning scalable and measured IT resources. Similarly, cloud computing is the delivery of computing resources over the internet on demand. So cloud, we can just imagine, we can visualize, it's a very big what we can call it's a very big house, we can call it. We can just imagine or visualize a very big apartment otherwise, where there are hundreds and thousands and lakhs of computers there which are ready to provide the computing services, like for the computing, like for the storage, like for the networking, like to provide the platforms, and like to provide the software services. So like that, many computers are installed at some place in a very huge manner, like a big shopping mall, like a big apartment otherwise, a big house otherwise. So there are some hundreds and thousands and lakhs of computers are there which can compute, which are ready for the storage, and which are ready to compute something, and then where it provides some facilities like platform it will provide, and it will provide the software services and even hosting services also. So that is something about the cloud. We can imagine a big thing where, of course, the people are ready to, the people around that house, they're ready to have the services of the cloud. But let us understand, so that is something about a cloud. It's a big computing area, we can imagine, where it provides us various services there. Okay, then, so why cloud at all? Why we need this cloud computing at all? So if you see, for example, we want to start our own startup. I have my own startup, or you have your own startup there, means our own premises there. On premises means, yeah, our own IT company. So if you start your own IT company, so we need to, first of all, what is the biggest problem? Investment. We need to invest a lot for our resources. Then we need to scale up, means we need to increase the systems, increase the servers, buy the softwares, and all investment we need to increase, basing on the applications, basing on the projects we're getting there. Suddenly if the projects get down, what is there? So, we can't again downscale it. Investment is already done. It's a loss there for the individual person. So then if in that case, so cloud is already existing, a big house is there. So what we can do is simply, of course, we can use the services provided by the cloud. Why? Because the complete infrastructure is built up there in a big manner, in a huge manner. So on premises, there is a lot of risk there. Investment is risk, scalability. Sometimes we need more, and sometimes we need to get down. So again, what we do with it, all the infrastructure will be kept idle there. But cloud means if you how much you want, you use it and pay for it. You don't want that many services there. You want only limited. Use the limited services and pay for it. So that is the advantage of cloud in the first point of scalability. So if you have more requirement, you take more services from the cloud and then pay for it. If you need less resources, use less resources and then pay for it. And server storage. Even if for the same startup company, we need a lot of server storage space. Even that is also incurs a lot of expenditure, a lot of cost. But already we have a big storage there. So nothing to explain here. So the cloud is built up with a lot of storage by Amazon Web Services, Microsoft Azure, and Google Cloud, and etc., etc. So they have a lot of storage there, and they'll provide it for a very minimal cost. If we need to install, it takes a lot of money, a lot of investment. if we go for a cloud, it takes a minimal thing. Comparatively, it's very less. So then the third one, data. One second. So the other one is data security. So for our in our company, in our system, otherwise in our startup company, for security we need to take a lot of measures there. The data can be hacked, the data can be corrupted. A lot of security, people will hack all the time. Today is the, people are hacking like anything. There are more vulnerabilities, at any point, like people are trying to hack the data. So security, if we need to provide, we need to take care of a lot of that. Security itself is again a big task for our on-premises, means for ourselves, for as an individual, for our company otherwise. But if it is given to if we take the service from the cloud, it's already masters are there in that. They use some beautiful encryption algorithms there, some wonderful security algorithms there. So what they do, we need not bother and worry at all. They'll simply take care. Our data is very safe there. If we need to handle, we'll have a lot of fear. Why? Because anytime the data breaches will happen, the data may be hacked, the data may be lost, and people will, steal the data, of course. So like that is the security aspect. So cloud service providers will give a wonderful and happy security, safe security, of course. Okay. In the same way, the next point is data loss. For some reason, if the data got corrupted, if the data is lost, or the devices got malfunctioned, then at our point, it is very difficult to recover the data. But at the cloud's side, there are a lot of recovery tools there. They have a lot of they'll have a lot of backups there at cloud. And they have a lot of recovery tools also. So in the next second, they'll give the data, whatever we feel if something is lost. But at our place, it's very difficult to have the backups again and again to recover the tools. As an individual, it's very difficult comparatively. Okay. So yeah, data loss is done. Maintenance also, the software maintenance to be taken care and the hardware maintenance to be taken care. Many people should be employed for the hardware maintenance and the software maintenance, but everything is taken care at the cloud by the cloud service providers itself. A big team is there. So they'll maintain the software and then maintain the hardware and see that the data is proper, safe, and reachable. So anytime you want, yes, they'll give. We can access it. So like that, this is the basic content. Why cloud computing at all? So these are the things: scalability, server storage, data security, data loss, and then the maintenance also. So what is cloud computing? So then, like, we have basically cloud computing deals with two models: deployment model and then service model. So deployment model. So for example, yeah, I want to use the cloud now. I have my own applications. I have my own data. But yes, just now as we saw the advantages, I'm so scared to keep all the data and applications with me. So expensive also. So it's not secure also. See, it's not secure. Maintenance cost, it takes a lot. Data loss may happen. Similarly, storage space, all the investment, scalability. Somewhere I need to scale it up, and somewhere at some time I need to scale it down. So like that, all these issues are there. So yes, if at all I want to go for the cloud, yes, all my applications and all my data, I can deploy it public cloud or private cloud or hybrid cloud. Public cloud means what? Yes, it's a cloud space again, where many people like me and some of you people, you have your own applications and data. So all will, like it's a public park, all will come and they'll deploy their applications and data there. But of course, what the cloud will do is, cloud service providers, they will provide the security. So the data is maintained, the confidentiality is maintained there. So as it is public, like, once data will be seen or will be accessed by some other people, no. But the public cloud is simply, yes, all the people as a public place or a public park. So many people will deploy their applications and data there, so that the cloud service providers will do all the required services, will provide all the required services. Private cloud means, yes, I want my data in a separate space, not with the public. Yes, that is also done. So like means previously public cloud means like it's a public bus, public transport bus. This means having our own vehicle, which is our own car. So like that, there is a big cloud building. So I want my private cloud. So no, I don't want to mix up with any other people. Yes, that is also provided. So then of course they'll charge in a separate manner. So our data is kept separately and it is maintained by the cloud service providers or the third parties. So that is another thing. Hybrid means combination of both the things. Somewhere people can go for the public and partly something can be private also. So this is about the deployment model. And if you see the service model, this is the actual main content of the thing of the cloud. So service model, it provides 3 services: IaaS, infrastructure as a service; IaaS, PaaS, which is platform as the service; SaaS, software as the service. People, some computer science people may be knowing the content, but yes, I heard, the many interdisciplinary students are there. So that's why we're, as sir also asked to go with the things. I'm just going slowly and concentrating more on this basic content. Okay, so that's why. So service models. So infrastructure as a service, platform as the service, software as the service. Imagine again the same big building. The big building is there. So yes, I want to have, I want only the computing. Means I want only the processors. Means only the computing systems, that's all. I don't want anything else. I want only the computing infrastructure. Then what it will do, I'll just show you here. So here what it will do is, you can just check the content here. So it will provide the remote desktop client. So this one, or the SSH client for Mac operating system and Linux-based operating systems, Linux-based systems. So if it is Windows-based, it is, they'll provide a remote desktop. So imagine the same big building. I want only the computing service, that's all. So then some desktop, if it is Windows, they'll provide the desktop. If it is Mac or Linux, they'll provide SSH client. So if we clearly observe, here, see, IaaS, we need to, means only we need what? Only the processing, the computing. But all my applications, see the blue thing, applications we need to give them. And we need to give the data. Why? Because they'll give only the processors, the desktop systems. Only it can process it, that's all. Only it can compute it. But yes, we need to give our applications, we need to give our data, the runtime environment, of course, in which tools you want, which OS you want, everything we need to give the runtime environment also. Why? Because they are only processors there. Middleware, any middleware between the applications and the OS, and followed by operating system also. Okay, so all these things should be provided if at all you want to go for only infrastructure as a service. So this is the first one. So see there. So we have the remote desktop and SSH client also. If at all you want to go for this service, means I want to have only computing from that building, then I need to provide applications and my data, my runtime environment, and then middleware, runtime, my own tools, of course, to run my applications, and then middleware connecting the runtime and operating system also. Okay, so then the next one, if you see the PaaS, platform as as a service, the second one. So to actually understand like what are the our basic content to deploy our AI models in the cloud, so let's actually have some basic content what is the cloud and all. So then we'll have the clarity. So how to go for it and what are the available facilities we have. So like that we can go. So that's why let's have slowly the basics of all the content, all the basics of cloud. PaaS means what? Platform as a service. Means platform means what? The actual environment. You have your applications there. For example, see here. So you have your, you want to run your applications in the data. So I want the actual platform required. Means only your applications and data you will give, but all others, see their runtime, see the cursor there, runtime, middleware, OS, everything means the required environment. Means what? The operating system and the tools required to run your applications and the middleware, everything is taken care by the cloud. Your actual application and the data you should provide it. If at all you want to have the platform means what? The environment. The actual working environment means the operating system and the actual tools required and the middleware required. Of course, all the other things, virtualization, servers, storage, and networking also, basing on your application. So, but here in PaaS, only we need to give the cloud service providers or the cloud people only our applications and data. So previously we need to give 5 components, but here only 2 components. Why? Because I need the platform, I need the running platform, I need the working environment. So that is provided by the cloud. And the third one, the SaaS software. I have my application, I have designed my application, for example. So I have my own application, maybe a service-based or product-based or some sort of application. You have your application and I have my application. I want my application, I don't want to handle anything at all. Simply, I want my application to be taken care by the cloud. So then what? I can just hand over everything. Means all my application and everything will be at the cloud. Nothing will be at the client. Means we people, me and you, will not have anything at all. Only we should have a system with the internet so that we can access our application through the internet. That's all. So software as a service. All my application will be completely deployed in the cloud, and the data, the runtime, OS, middleware, everything is in the cloud itself. So nothing at my place. So everything is taken care by the cloud itself. Simply from my system, we'll try to access our application, of course, to the cloud through the internet. That's all. Okay. So this is the third model. So service model, we have IaaS, PaaS, and SaaS. Infrastructure is first one and platform is the second one. Software as a service is the third one. So this is very important. So what you need. So accordingly, you can go with the cloud. You know, we have a big building of the cloud. So yes, somewhere I will computing, go for IaaS. You want the platform also, go for PaaS. And you want completely taken care by the cloud, just go for SaaS. Of course, accordingly they'll charge, of course. Accordingly they will charge. Okay, so this is something about IaaS and PaaS and SaaS here. See, I'll just show you something here. So IaaS, remote desktop, and this SSH client also I've shown you. So this is here. So see here, the desktop client and the SSH client. Only the computing computing claims are we have requested, and of course they're offering it. They're providing the service only with the clients. And this is what, see, the separate environment is created for us, which contains actually the software to run applications and all. And then the maybe see SDK, IDE, whatever the required things, whatever. My application, you know, needs some extra tools and the environment. Everything is provided by the PaaS model. So this is the second one. And third, see here, collaborative authoring and information, Wikipedia, Blogger. They are the actual softwares or some applications of some other people. So it is being completely taken care by the clouds. Netflix is the best example, completely taken care by the cloud. Nothing they'll do it. So the Amazon Web Services is the top, of course. He's the out of all the cloud service providers, Amazon is the top, which is taking a big share of the revenue. Okay, so Netflix is one of the main client of the AWS. Why? Because we know Netflix. All the content, simply they'll just dump it in the cloud. They're not bothered about how it runs, the data, the security, everything is taken care by the cloud people, the cloud service providers. But Netflix, they'll give some charge there, that's all. But very minimal. But if at all they want to maintain on their own, it needs thousands and lakhs of millions of dollars. So simply now, maybe not that much. Yes, they do charge, but compared to the investment, but it is very less there. So Netflix is the best example. So I just want to tell all of you. So AWS, the best client is Netflix. It's giving more revenue to the AWS, that is Amazon Web Services. And then see the next one, collaborative management, Zimbra and Google Apps, and then Skype, some messaging software like Skype and Google Talk. And then the other one, so enterprise management systems, ERP, CRM, and CM. You people know some tools and applications here, some applications, sorry. And then file sharing and content distribution, YouTube and Dropbox, and any industry specific software, which is engineering and bioinformatics, email and voicemail, everything. It is taken care by the software as a service, SaaS models. Okay, so like this, these are the examples, of course. Then, so what? So how, so there's a big building and there are a lot of people who need the services. So some people take IaaS as the service, and some people take PaaS as the service, and some people take the last one, SaaS as the service. IaaS, PaaS, and SaaS. So then obviously the cloud service providers, what they'll do, they'll charge us. So how they'll charge? Of course, we need to know this point also, simple, but we need to know. So basing on the requests, basing on the response messages quantity, how many requests we are sending and how many responses they're sending. So they'll just monitor everything. That is the first thing, like they're going to charge us. And then basing on the transmitted data volume, how much the data is actually we are uploading or we are downloading, basing on that also. And then the bandwidth consumption, how much bandwidth is being consumed. So like according all this, I mean, as per these 3 points, so the cloud service providers are going to charge some, they're going to monitor and then they'll charge us. Okay. So like this is the very important, because the very basic concept of cloud is what? They have built up all the basic infrastructure where the processing, the computing facility is given, platform is given, and software service is given. And then maybe the hosting facility they're doing, and then the networking, and then the storage, everything they're providing. And of course, they'll have a pay-per-use, they have a monitoring system which will monitor basing on these 3 points. The messages, the flow coming in and going out, and then the data volume, and then the bandwidth consumed. So all these things are the main parameters as per they're going to charge basing on these 3 parameters. Then, so like this, you can see the monitor, pay-per-use monitor. Okay, and then if you see so these are the actual basics of our cloud content, cloud computing or basic cloud. And then what are the platforms available there to actually, so this is the actual topic. So what are the available platforms? Which is it paid or is it unpaid, and how to go about it? We need to know some service providers, of course. Okay, so see here. The first one, the paid, if you see the paid one, let's see the paid and non-paid also. In the paid, we have the first person as Google Cloud Platform, GCP. So they'll provide tensor processing units, TPUs. And then they'll provide the GPUs also. You can see at the down. So GPUs and TPUs also provided. but this is a paid thing. Okay, so let's see what we have, what we can do, so that and how to go about it, we'll understand. So this is the one of the platform, all the people we know it, Google Cloud Platform, the very famous. And this is the, of course, this I need to put it first of all, why? Because this is the highest share taker. Out of all the clouds, Amazon is picking up the biggest share from the market. Netflix is a simple example. Like that, many companies are tied up with the Amazon Web Services. They are using the cloud facilities of the Amazon, and then of course these people are taking the biggest share in the market. So here, even these people also, they paid this one, AWS SageMaker. So previously, Google GCP, we call it as GCP. So it is Google Cloud AI, and here it is AWS SageMaker. So this PPT, of course, will share it to you so that you people can browse it, and somewhere if required, we can go for paid or we can go for non-paid. So even here also we'll have the facility for the GPUs and NVIDIA graphic cards. So all the facilities will be given by this Amazon. So see, the SageMaker, it is used for building the applications and training them and deploying the deep learning models. Recently, AI has become so popular, people are using like anything. Everywhere the AI is there, everywhere. The farmers and the cancer research, everywhere, the doctors, drones, meteorology department, everywhere, the student, any bank organizations, hospitals. So AI is there. So what? So we can build the applications, we can train the applications, and we can deploy it using the deep learning models. So this AWS SageMaker is one of the cloud service provider, of course, which is a paid one. So then the next one is Microsoft Azure we have. Even this also provides mainly for the computer vision and natural language processing. Okay, so almost it'll help us in the ML model training and development. So this is Azure AI. Okay, even this is the another paid one. And IBM, which is very old, this one cloud provider, service provider. So IBM Watson Studio is the actual cloud service provider. So even this also for the deep learning and machine learning workflows, it is used. And then Oracle Cloud Infrastructure by the Oracle Cloud. These also provide the GPUs and NVIDIA facility. So for more graphical processing, high performance bare metal and VM instances. Sorry. Okay. And then the next one, we have Paperspace. Even this is also for the deep learning workflows. These are all the paid components, paid service providers. And then we have Lambda Labs, which are provide the NVIDIA GPUs like A100 and V100. So where TensorFlow and PyTorch are pre-installed, which is Lambda Labs. So these are all the paid, but yes, we need to focus something here. Why? Because yeah, people are more prone, or anyone can just go here. So that's why. So non-paid cloud platforms. I think almost all of you know it. So Google Colab. But some components will understand, and some people something will know now, so that people can use it, people can know it, and people can use it, and people can of course they can build, they can train and deploy your own AI models. Okay, deep learning models. So what? So this Google Colab, they will provide the GPUs and TPUs also for free. Google Colab. So many people are working with the Colab software, but we don't know. We think like, we are just running the application and it's simply running. We are, working on application. We are just coding some content as per the requirement, and then it's running, we thought, but actually the GPUs are provided. If it is still required, the TPUs are also provided. Tensor processing units. Okay. So this is Google Colab. And then the next Kaggle. So Kaggle is also recently, Kaggle is very famous for the data sets. but it is coming with the Kaggle notebooks also. It is also giving the Kaggle notebooks where we can code our own applications free. I don't know how many people have already used or people know it. So Google Colab is one and the Kaggle is another one. So then the next one is Gradient by Paperspace. So even Gradient notebooks, free Jupyter notebooks, and GPU support is given by this cloud service provider also, of course, which is free again, this one also. Okay. And then Azure free tier. So here free service for 12 months and limited GPU access available, and Microsoft Azure it is. And then AWS free tier. So they have some people, they have their own restrictions. So 750 hours per month of EC2, and free tier includes T2 micro instances. GPUs are not included in the free tier. Some people, they give some sort of, they'll pose some restrictions. So this is AWS, which is the top share person. Okay. So in the free market, it is, they have some restrictions. And IBM free tier is also there. So where these people also are giving some basic GPUs. Of course, we have some restrictions there, but yes, we can utilize this cloud services free. Hugging Face thing, even this is also free. So these are all like we people can try. Colab and Kaggle people are aware, but other things also we can try. So which are free, non-paid. Okay, even free hosting for machine learning models and applications, and this is another one. And then Google Cloud free tier. So here I think we need to pay some caution deposit like $300 there for 90 days, and then of course then it'll be free for the complete year. They'll provide the GPUs and TPUs also, but initially that $300 should be credited there for 90 days. Then it'll be free for the complete year. So this is by the Google there. Okay, Google Cloud free tier is something different. Google Colab is different. Okay, Colab is completely free. It is Cloud free tier. They'll have some other features there. So that's why they charge some content, some minimum of $300. Sorry. And as a cautionary deposit, that's all for 90 days. Then, so this is the overall summary table. So what are all the AI platforms, the cloud platforms we have, where we can go for, which is paid service and which is free tier. So we can see all the things in a single table. So Google, just go through Google Cloud Platform. If it is free, 300 credits we should be created, and then if it is paid, TPUs and GPUs will be given. Amazon Web Services, 12-month tier, and EC2, SageMaker and all. Microsoft Azure. So just go through AI Studios and GPUs and IBM Cloud, Paperspace Gradient and Google Colab, Kaggle, Space, and all the things. This is overall, what are the platforms available, which are paid and which are unpaid, which are non-paid, of course, which are free. Okay, so then see this, the main content, like we need to know, all of us, we need to know. So Google Colab, we think like it's some editor, some Python editor. Yes, where we can have our machine learning algorithms or the deep learning algorithms, but it is providing the GPUs behind and the TPUs. So GPUs are graphical processing units. Graphical processor simply. They're not the normal processors. Normal processors can handle text data and to some extent image data or video data or as a text data like that. But graphics GPUs, which are graphical processing units or graphics processors, now if we understand, yesterday we have understood something about the convolutional neural network, where we deal with some hundreds and thousands of images, and every color image, again, it takes a lot of pixels and a lot of size. So normal processors can't work. And i3 and i5 processors, it is very difficult. Maybe some people may be knowing it. i3 and i5 processors, with the normal RAMs, maybe 8 GB or even less than 8 GB, it is very difficult for i3 and i5 processors to run the CNN applications. If the data is very less, of course it works. But if it is the images are 50,000 and 1 lakh and even more and more and more. So the processors, normal i3 and i5 processors can't work. We need to go with i7 processors or GPUs or even TPUs also. GPUs means graphics means mainly deals with the images and videos there. To process more images and more videos, so mainly the GPUs are used. And TPUs, if you see there, see what are TPUs? They are mainly tensor processing units, tensor processing units. They are custom built ASICs, means application specific integrated circuits. So if I have some application from my side, so some TPU is designed for it. Maybe I have my image oriented application, which is completely, I have a specific domain, some application in some domain. So obviously I'll have some TPU for my domain. It is custom built, application specific integrated circuits. So exclusively TPUs are made for some applications. They are customized for some videos, for some images, even for text also. Okay. So like that, TPUs are, which are very powerful than GPUs. Normal processors, we all know Intel processors, i3, i5 and i7. i3, i5 are, the basic processors, but i7, it's okay. We can run the CNN applications, the machine learning and the deep learning applications. But GPUs are still more powerful. TPUs are still more powerful, which can work for some specific applications. Maybe they are very exclusively more size in data and more size in videos and images and like that. But TPUs also, TPUs are more powerful comparing to the normal processors, then GPUs and then TPUs. So like that, see there, the default GPU for Colab is Tesla K80 with 12 GB of VRAMs. See there, the RAM is also, it's not normal RAM, sorry. It's not normal RAM. It is a video random access memory exclusively for video processings. NVIDIA is a graphic card, very powerful graphic card. So the GPU, the graphical processor is integrated with this NVIDIA Tesla K80 and the 12 GB of VRAM. So like that, the Colab with, we all need to know. So Colab means we'll simply think, yes, there is a plain white editor. We'll type the code and it is running. But behind the screen, all this content is running all the time. All the content is running all the time. So GPUs and TPUs are there. Okay. So like this, so GPUs have some Tesla K80 and the RAMs like that. And then you can choose, yeah, if required, it increases the GPU's processing capacity and even the RAMs also. Even TPUs also, please check it here. We need to know all this data. So then we can be confident, yes, we can go with any cloud or not. So we need to understand all this terminology. What is a cloud and what are these computing, what are the services, what are the GPUs and what are the TPUs and all. So then accordingly, of course, we can plan and we can do it. That's why. Okay, so even TPU also, we have V2 and TPU V3, which are equipped with 8 or 16 GB of high bandwidth memory. Okay, so TPU, they are specific, application specific process. Now, so these are all the actual content of the basics of cloud and what are the paid services, paid cloud service providers we have and what are the non-paid cloud service providers we have. And of course, Google Colab is one of the free or non-paid cloud service provider, and we have understood the basics, the behind the screen means what are the infrastructure we have for the Colab. We have understood, so that yes, we can confidently deploy our applications, let it be of any size. Okay, then. So I think yesterday we have, I don't know how many people remember, yesterday we have seen the basics of neural networks and then one of the important deep neural network, which is convolution neural network. So perceptron and then multi-layer perceptron and then the backpropagation neural network and the convolution neural network with the black and white image and then with the grayscale image and then with the color image also. I've tried to explain every nook and corner, every point of how exactly the convolution is happening there, how the pooling is taking place, every pixel, every image, how it is converted. If it is black and white, how it is converted into binary, and that image, how it is convoluted, how it is the pooling is done, how the max pooling is done, and how the flattening is done. So everything we have actually understood, and what is the stride there. And again, image can be a black and white or a grayscale or even the color also. So we have seen in a clear manner yesterday. So now that convolution neural network, of course, we have understood about something about RNN also. So these days, the mixture of CNN and RNN, there people are running. RNN is exclusively used for text processing, and CNN is basically for image processing. Okay, image detection or image processings, mainly CNN. RNN is for text processing, but somewhere I need the text and somewhere I need the images also. Then people mix up with the CNN and RNN. Yesterday we have seen four types of RNN, four different types of RNN models. So one-to-one and one-to-many and many-to-one and many-to-many. Okay, so like that we have done it. But today, yes, we have understood CNN yesterday. Now let us actually run our CNN model in the collab environment. Why? Because we have understood collab means it's not a normal thing. Why? Because other things, paid services, it's very difficult, and even other free platforms also, they ask to go for this, we need to sign up, and a lot of process there. So collab we'll see how the cloud will actually help us in running the CNN model. So yesterday CNN we've understood. Now let's actually run the program so that we'll understand how the cloud is going, actually providing the services there. Okay, so then this is something about it. Now, 1 second. So the application is ready here. We'll understand the application also, the code also, 2 minutes. Then we'll actually run it. So this is the Colab, Google Colab editor. So if I'm just leaving this Colab like this, after some time, maybe of 1 minute or 2 minutes, I'm getting a message. The GPUs are being kept idle. What are you doing? You want to run or not? It's saying every now and then. I think they have kept an alert or some reminders. So means as we have discussed now, so this collab is surrounded by, or it is backup by some GPUs, even TPUs also with high speed RAMs. Okay. Now, so let's understand the CNN model now. Yesterday we have understood the actual concept. We'll see. So I'm not going to explain all the code, but basically whatever it is required, I'll just explain. So see here. Here there is some data set called CIFAR10 where there are 60,000 color images of 10 classes, 10 different classes, where 6,000 images in each class. So 6,000 into 10 classes, total 60,000. That we need to understand. So then the data set is actually divided into training and testing. So maybe to make you aware. So first of all, if there is any model, machine learning model, any model, we need to train the model. So the first image, yesterday we have seen, for example, black and white image. What? It is the convoluted. Something I'm just mixing the yesterday's topic. Why? Because actually both are same. Both are connected. So we have understood the basic neural networks and how to deploy in the clouds, that we are seeing. Okay. So now see, for example, there is a CNN model. Imagine the yesterday's content. So the black and white image, it is convoluted, and then max pooling is done, and then max pooling is done, of course, with the filters in the middle. So then it is flattening is done. It is then the input layer, hidden layer, and the output layer. So some output will get it there. So the input is the image, and output will get some. It will be trained, of course. First of all, it will be trained. So see here. So 50,000 images are trained. So then there is, see, I should explain something else also. Imagine, yeah, I'll just show you this. Yeah, see the classes. For example, first one is what? Airplane. Or I'll take the bird, that is better. Bird is there, some bird is there. Let's understand now. There is a bird, 6,000 birds are kept there. Same birds, of course. Same species, of course. So 6,000, but what? The images will be in different postures. Something at the left side, something at the right side, something from the top, and something from the straight, something maybe in some other angle. So all the birds, 6,000 images. So the first image is given to the CNN model. Yeah, it'll understand. Yes, this is this bird. Next image, so out of 6,000, second image, same bird. It will be trained. So see, we have some filters yesterday. We have used some filters. So some filter, it takes the vertical content. It'll just try to identify the vertical lines. Some the horizontal lines, some at the border, some at the center, some other lines, some other curvy lines, some at the boundary. So all the filters, the bird, even if it is in left side or right side or the top, so something is going to identify the ears, something is going to identify the eyes, nose, and the shape, the color, like that. All the 6,000 images during the training, what will happen? So the system will understand, oh, this type of image, if it is there, it is this bird, some bird. Similarly, what is the next class now? Cat. Take the cat. Even the cat also what? Different, the cats are, different cats are taken. Different cats are taken. The species is the cat only, but different cats. But you know, the eyes and the nose and its mustache, everything. And the left pose and right pose and the top and the bottom and the straight, maybe in some other posture. All the things. So again, it is the train. Please understand, the model will get trained now. So 6,000 images will be cats are trained. Not exactly 6,000. I'm just telling you why, because some only 50,000 are taken. Out of 60,000, only 50,000 means 10,000 are taken off. Maybe around 5,000 or 4, 5 approximately. 4,000 or 5,000 images. See, one image we've understood yesterday, CNN model. So like that, 4,000 or 4,500 models, it'll understand if image is given. Yes, it will tell this is this bird and this is the cat. This is the airplane. See the classes what we have there. So something is aeroplane and automobile. The cat, deer, dog, frog, horse, ship, and truck. So please understand the model should be trained first of all. Once the model is trained, yesterday, imagine all the CNN model yesterday's. Once the model is trained, now give the test cases now. Give any other very unique image of the bird. Very, it's not, the photo is not taken properly at all, but the same species. Obviously, it has already, it got trained with some 4,000 and 4,500 images. It obviously tells this is the bird. Generally, it just gives the right answer. Somewhere it may miss it. Some images it may miss it. So out of testing 10,000 testing images, so 10,000 means what? Yeah, exactly. 10 classes, na? Yeah, all the classes are 1,000 test images are given now for every class. So there are 5,000 images for the training part. So please understand. So 10 classes, each 5,000 in the training. So the model got trained. Now when we go for the testing part, it will actually test it. And it will give the answer, right answer. Somewhere it may become wrong. It may tell something else. So that wrong things will be how many right and how many wrong. So like that, accordingly, accuracy is calculated. That is a separate topic. We can't go there now. So like that, so accuracy is also calculated. So this is something I want to just explain today also. So this is the basic content now. So 6,000 images where 5,000 for the test training part and 1,000 for the testing part. 5,000 into 10 classes. All it is trained for the SDS CNN model. Okay. Now, so of course, these all the things are there. Some whatever it is required, I'll just tell you. So see here now. So the pixel, each image pixels are, see the cursor, see my cursor there, 32 by 32 by 3. Why 3 it is? Yesterday we've seen color image means 3 red, green and blue planes are there. So 32 is the pixel size and 32, of course, 32 by 32 is the pixel size. And 3 are for red, green and blue. So like that, they have created the convolution layer, max pooling, and then the convolution again, and the max pooling and the convolution again. So like that, see the ReLU activation function also, yesterday we have understood. I don't know how many people have understood yesterday, but I have tried to actually explain each and every topic of the neural network and even the deep neural networks. My sincere thing, like very important yesterday's topic. Okay, the ReLU is one of the standard activation function, rectified linear unit. So so that is given here. Then, so again, like what we'll do is, so here again, you see the flattening layer is given. Again, once again the output layers and everything is created. Sorry, and then model.summary. We'll actually compile the thing with the optimizer as Adam, and then so the matrix is accuracy. So fit the model with the train images, train labels. Epochs is 10 here, 10 epochs. Yesterday I told you, one time if you run a back propagation, if you see there, so all the data set, if it is run for once, that is one epoch. For example, I have 500 instances, 500 records. All the 500 instances are run through the model for one time is called one epoch. So like that, we have given 10 epochs here. Okay, then, so this accuracy calculation, they are giving all the what is the epoch and accuracy and all. So then, so mainly the model dot evaluate test images. We'll actually train the model. So how we'll evaluate? We'll evaluate with the test images. So and then finally print the test accuracy. So this is the actual overall thing. I didn't explain each and every line, but overall I've tried to explain. So now let's actually run from the beginning. So this is the Google Colab platform, the CNN platform, CNN code with 6,000 images. So initially I'll run. So every cell we need to run it. See, you're connected to a GPU runtime, but not utilizing the GPU. It's giving a warning. And then we'll run this. See, the data is being downloaded. You can see the line. It's working. Takes 1 or 2 minutes. Need not worry. So all the images are downloaded. Then see the data. Some sample data they given here. Different classes, na? See deer, truck again, frog, automobile, and bird, horse. Please see, this is another bird and this is another bird. So overall bird, I think they're trying to classify it. So horse, truck, some images are shown here. Now we'll run this. Actually, the hidden layers and everything is created now, the convolution process and everything is created. We have created. So everything it is showing, convolution layer, and then max pooling layer, convolution again. The convolution, to actually, they'll go for the second time again, they'll convolute it. Again, they'll go for convolution. So those are all the at the last slide I've shown you. Convolution neural networks, various architectures there, VGGNet, ResNet. So, they'll go for still sort of refining the model. Once again, going for pooling, and once again going for the convolution, and somewhere they're going to convolute in some other way. So like that, they're going to I mean, people have come with various CNN architectures, and it's actually working with good accuracy. And lastly, even here also this thing is done here. Also, even here also it has created the once again, and then we'll actually compile the model. Actually, we have run the model now. See, the epochs are running. It just takes 1 or 2 minutes. Nothing to worry. Second epoch. Please see the same if you run on your system i3 and i5. So it'll not run. Some systems it will not take also. If you just run the same code, it's very difficult for the normal systems, normal processors i3 and i5. i5 maybe chances are there, but i3 is quite difficult to run the CNN Pro. See how many images? 6,000 images. Sorry, 60,000 images. So these 10 epochs, it is run in just a fraction of seconds. 8th epoch, 9th epoch means those many number of times we have run the same model. Please understand, all the 50,000 training, it is run for 10 times. Model. So after running training and testing, we'll evaluate it. Means how is the training and testing. So this is the curve we got. And finally, we need to print the test accuracy, which is around 69.2. So around 70. So in just 2 minutes, the collab is helping us to actually run our CNN model. Yesterday we have understood the CNN model. Now we have actually seen the actual code, how many images we have taken, how many training and how many testing, and how the layers are created. Not the complete code, of course. I've tried to give some overall idea. So now we have tried to implement it in the Google Colab platform, which we think it is a normal thing. Of course, people are using, but we need to know the background content. What is the infrastructure of this collab? So, see, previously when we are actually running something, the GPU you're not utilizing properly. It is giving some alert messages there. So I hope people have seen it. So like this, we can run the CNN models. So what I want to tell you, so the CNN model, the small code we have implemented like this. Any sort of AI application or deep learning application or machine learning application which deals with images and videos, we can use the Google Colab and a lot of other free cloud service providers, which we have shown you in the PPT. So even paid also people go, if at all the applications are, maybe if there are some companies, startup companies, they need some very good computing and good processing and maybe on time and with a lot of security and all. People are going for paid also, some startup companies. But as an individual, I think we have this collab is there and followed by many free cloud service providers are there. I think that we can avail the opportunity and the facility, and then we can deploy our applications there. Of course, we have shown you through collab. Similarly, all the non-paid or the free cloud service providers, we can utilize them and we can actually deploy them, and then we can grow in our careers. So this is something about the CNN execution. And then, yes, so that's from my side. So now, any doubts, please.
Sir, sir,
All the participants, I request maybe if you have any doubt, yeah, please, you can raise the
sir,
question so that I'll
sir,
try to
what?
answer.
Excuse me, sir. Sir,
Yeah.
what is the advantage of using cloud for AI platform, sir?
Yeah, the advantage of using this AI platform, like, yeah, of course we have seen, but I'll just try to answer there. For example, I have a startup, I have my own startup, or I'm designing my own AI application there. So when we actually design an application, so running some applications need GPUs and TPUs, where I don't have my system. We can't invest that much money there. So then it is very important or very useful to go for this Google Colab or the free things which are given by Google, and then Amazon, and then Microsoft, and then IBM. So then we can just, when we deploy it, see, we don't need any our hardware resources and the actual infrastructure what is required. So everything is being provided by the cloud there. So that is the advantage, and followed by the actual computing, the RAM and processor, we can't afford for that infrastructure. Why? Because machine learning algorithms or the deep learning algorithms exclusively need lot of computing facility and lot of big size RAMs. That is simply GPUs and TPUs are mainly used where we can't afford it. So that is the biggest advantage. If at all we go for the cloud, yes, we can deploy it there. We can get even take the Google Colab. In just 2 minutes, we could able to run it. The same try to run. I'll just share the code also. If you have your systems, if you can run it, yeah, it takes a lot of time, and some systems it won't accept also. Why? Because the RAMs doesn't support and the process doesn't support 60,000 images there. So like that, the running on the cloud, it is the biggest advantage we can have in very less time. In the Collab or any free cloud platforms, cloud service providers, we can use it, and which is very secure, and the infrastructure we don't need, which is very faster also. So it doesn't waste any time. So hope I've answered your answer, sir.
Yes, sir, yes, sir. Further, can we take any precautions to be taken before deploying, sir?
Yeah, the precautions means mainly as a sort of, I'll just show you here. Precautions means we need to be clear about these things. So what is your application there? And maybe how much you can afford it, for example. So the precautions mainly for security aspect, or what is that? Data recovery, or all the thing we need not worry. Why? Because everything, it is maintained in a very confidential manner. The security, see here, the security or the recovery or the laws, anything is taken care. Why? Because they are all built with the masters, the softwares and hardware, the big teams are there. So basically, we don't need any security, any precautions, but we need to understand what service we need, basing on our, of course, how they're going to charge there. So accordingly, if at all my application completely I want to just base on them, so go for SaaS. No, I want basically some platform. If it is enough, then go for the PaaS, which is platform as a service. No, I want to go for only infrastructure, only computing. I want only the process. I don't require anything else. So then go for IaaS there, which is infrastructure as a service. So precautions we need not take. Why? Because the Google, the cloud platforms or the cloud service providers, they take care of everything in a better way, in the best way, security
Okay,
aspect or a
okay, sir.
confidential
Understood.
aspect, anything. So only we need to
Yes, sir.
take care of the service models. That's all. How we are going to go, which model you want to prefer, basing on the revenue.
Thank you, sir.
Is it okay, sir?
Thank you, sir. Good, sir.
Okay. I request the participants. So yesterday, the neural networks, any doubt yesterday's or today's, I'm happily inviting but this is not the right time. Why? Because it is your sleeping time, and from the morning people got fully tired in your works. But maybe people, if you have any small doubts or any sort of doubts, please you can ask. I'll try to answer. Otherwise, I'll let you know later also, at least. Any
Sir,
doubt?
can you share the PPT, sir?
Yeah, I'll share it now itself, sir, to you. So you
Okay.
can share to
I
your all
will
the
give this
participants.
drive link, sir, for this.
Sure, sir. I'll share it to you.
Okay, sir. Thank you so much, sir.
So hope
Yes,
the basics of cloud were covered, sir, as per your request before.
yes, sir. That's
Cloud
I expected, sir.
and
We
the
expected.
collab also the running as you have asked. Like
Thank you so much, sir. We expected the same thing.
we have taken the CNN model and tried to
Live
SD.
example. Most of the participants don't know, sir.
Okay,
That's why I
SD we have
requested
understood
you.
the concept there, and now we have tried to implement it. So how the
Yes, sir.
actual cloud is going to help us with the infrastructure as with its infrastructure.
Okay.
I think I have done my thing. Maybe the participants should tell the answer, should respond. Like people are not responding, the participants.
Sir,
Yeah, sir, David.
sir, I have one doubt, small doubt.
Yes, ma'am.
Actually, sorry, my voice not getting properly.
Okay.
You said that CNN is used for image data and RNN is used for text data.
Generally,
Actually, for my project, I am using time series data for text series data for CNN only, sir. Which one is better? Is it CNN or RNN?
so generally, of course, CNN is meant for image processing and RNN for text processing. But now,
My data set is numerical data set, sir. Numerical time series data set.
better go for this RNN variants, madam. Recently, LSTM models are there, long short-term memory models. RNN models are best suited there. They're the
Okay,
best
sir.
ones, RNNs and LSTM models, and in that many flavors are coming. Having different models in the same, like CNN. They are
And
coming up with different convolutions and different pooling layers there. Similarly, the RNN models also they are coming with various variant flavors there. So, madam, better RNN that
okay,
long-term
in my sir,
LSTM model.
in my data set, I need to capture short-term dependencies and long-term dependencies also, sir.
Okay.
Which models are better for RNN, sir, for recording the short-term dependencies?
We need to understand the data, madam. So then only we can tell. But generally, RNN is the RNN and RNNs and
Madam, you
LLM
can,
models are.
sir, madam, you can send some message, madam, to the sir,
Yeah, sure.
so that
Okay, sir.
sir will clarify those things, madam.
Okay, sir.
As it's research oriented,
Okay. Any
definitely
other
sir will help
questions?
you.
Any other questions? Thank you, madam. Thank you for the
Thank you.
question. At least
Thank
you
you,
have
sir.
asked.
Thank you.
Yeah. Any other questions from the participants?
Thank you, sir. I think nobody is responding.
Okay.
Let us wind up this session, sir.
Okay.
A big thank you to Dr. S.V.J. Reddy, sir, for an excellent session on this cloud platforms for AI deployment. Your talk was both informative, sir, and inspiring, and we are grateful for the knowledge and insights you have shared with us. Thank you once again for making this session a memorable one, sir. Definitely, we will communicate with you, sir. Please try to share those PPT slides, sir, so that I can circulate among all these group members, sir.
Sure, sir.
Thank you all the participants for your patient listening. Let us meet tomorrow sharply at 6 o'clock. The attendance is very important because the Zoom records all the incoming and out going, the timings and all those things. So please be careful about these timings. We have to give accordingly the uh, attendance. Those people who have this almost 80% of attendance, then only they are eligible for the attempt of this examination, the final examination. Thank you all. Uh, have a nice day. Good night. Thank you, sir.
Thank you, sir. Thank you for the opportunity, David, sir.
Thank you, sir.